Hey guys, how's it going? In my series about optimization of OpenJDK, in particular the transfer to method of input stream, today we will talk about the sequence input stream. If you don't know it, it's seldomly used, but actually it's very versatile. You can concatenate several streams into one. For example, if you want to concatenate the content of several files into one file, or just act as if there would be that large file, then SequenceInputStream is what you need, and I made it faster. I tweaked another input stream. As you know, I'm tweaking input streams currently when it comes to calling the transfer to method, because least of them actually are implemented. They all resort back to the original input stream code, which simply puts bytes from one location to a different location in the Java memory using a loop. And this is slow because you have to pull all the bytes into the Java virtual machine's memory actually just to push them back to some outside external stream. So this time I was tweaking the sequence input stream, and let's look into the code what I actually did. So we're ignoring the discussion here in the middle of the code. So what I did, actually, I implemented transfer to. It wasn't implemented before, just as I said. And what is the code doing? So the first thing I'm doing always in this kind of tweaks is that I implement the require null check here explicitly. You could say, well, this makes no sense because when this one is dereferenced later, then you will get a null point exception anyway. But this is a fail-fast pattern that the OpenJDK team applies everywhere. They want the checks right at the start, so if you fail really fast and have not squandered time, memory, or whatever. So this checks that out is already here, and when it's missing, you immediately will stop execution. So the next check, if you have checked one of my latest videos, I already explained what this check does, but I will repeat for you here. There may be subclasses inheriting sequence input streams implementation, and we don't know what the subclass is doing. They are possibly written by a third party, so we need to be careful not to break their existing code, which could happen because the original transfer to method, which was called when you are calling sequence input streams transfer to, was the code inside of input stream transfer to, and that code was in turn calling the read method. I'm not calling the read method, and that could make a difference inside of that other class. I don't know if such a class exists actually, but if there is one, I could break it by not calling read. So this is a safety check needed whenever you haven't prevented subclassing. So that's, by the way, a good trick to make your code easier. Write final everywhere so nobody can subclass it. I know there is a lengthy discussion about a final keyword, but if there would be final here, then this check would be obsolete, and that check costs time each time transfer to is called, by the way. So this is to guarantee that we are not in a subclass but in the original class. And when we are in the original class, now comes the optimization. Then we will call the original transfer to method. So this might be, for example, a hardware supported or operating system implemented input stream, which we are acting upon. So this is a high-speed transfer. For example, on Windows, you're able to get the bytes directly from a file cache, and you can put it direct directly on an output stream. So this offloads everything to the operating system. And this is a good thing because not having bytes pulled into the Java virtual machine really makes things much faster. So this is what you want to do. On the other side, there's a loop. So why is there a loop? The loop is because this is a sequence input stream. A sequence input stream is provided at least one input stream, but you can provide a lot of input streams. So it reads them in sequence. So when the first one is at its end, we will read from the second and from the third and so on. So this is what this loop is doing. We're checking, do you have more input streams to read? If we have, we call transfer to on that, and then we go to the next stream and so on until there isn't a stream anymore. Maybe this looks easy, but think of the following case. You have huge files. You have huge files and you want to concatenate these files. So like several megabytes or even gigabytes, and you want to concatenate them in a single stream. Why ever? For example, because you want to concatenate into a large file, or you want to push them over the internet or whatever. Then now what you're doing is that for each single huge file, you have the operating system improvements. If we are not in the original sequence input stream, but we are in a subclass, then we cannot do this optimization. So we're here calling the original transfer to method, which is really pulling all the bytes. And now we're talking about megabytes or gigabytes into the memory of the Java virtual machine. So you could imagine in that particular case, not in lots of cases, I don't know even people using sequence input stream, but when you're using sequence input stream with really large files to concatenate into another huge file, then now you have a real boost, and you don't have it when you override the class. So and you don't have it when you subclass it. So when you have subclassed sequence input stream, please copy that code so you're sure that the performance improvement will work with your code too. This optimization is found in JDK 20, and I'm really happy because JDK 20 has its freeze today, and so I got it merged yesterday. That's really cool. And let's have a look into the test. I don't want to go into all the details what this test is doing. When you are interested in all those details, please check this older video. I have referenced it here with a link that will go into the details of the test. I only want to show you one special thing about the sequence input stream, because all the rest is exactly the same as the test that you find in the video. So to not repeat myself, I only go into the sequence stream. And here you can find it. That is the only special case that this test is doing. I'm not just returning a byte array input stream as in the original video. Now I am returning a sequence input stream made up of two input streams. The first one being a byte array input stream and the second one too. And if you wonder what this is, the original code used a byte array to push into the test and to check if on the other side the output input stream recorded exactly that bytes. I'm doing exactly the same here, but with the lower half of the array and the upper half of the array. So in the end, the output stream must still reflect the full array. So that's all for the test. Again, if you want to know how to write such tests on the level the OpenJDK teams expects it, go into the original video and you will have the full explanation. Hope you liked that video as much as I did, and I would be happy if you give it a thumbs up, and please subscribe to my channel or even become my Patreon so I see you like to see more videos and I will then do more videos for you. Please check out OpenJDK 20. It contains several of my performance optimizations. Would be happy to hear from you what you think about them. Do they actually have a benefit for you, or don't you see any improvement? Please write into the video comments. And until then, I hope you have a nice time, stay safe, and as always, party on!